In this question, we're asked to prove that the sum from 1 to n of 1 over r plus 1 times by r plus 3 is equal to n times an plus b all over 12 times n plus 2 times n plus 3, where a and b are constants to be found. Now the first thing to note about this question is that 1 over r plus 1 times by r plus 3 can be rewritten as a over r plus 1 plus b over r plus 3, where a and b are constants that we can find. Now, in order to find both a and b, we'll need to first multiply both the left-hand side and the right-hand side by r plus 1 times by r plus 3. This leaves us with 1 is equal to a times by r plus 3 plus b times by r plus 1. If we let r is equal to minus 1, then we will have 1 is equal to a times, well, minus 1 plus 3 will just be 2, plus b times by, well, minus 1 plus 1 will be 0, so it'll be b times 0, and b times 0 is just 0, so we'll end up with 1 is equal to 2a, and thus a is equal to a half. Similarly, if we set r such that r plus 3 is equal to 0, then we'll be able to find a value for b. Well, when r plus 3 is equal to 0, it means that r is equal to minus 3. Well, let's set r is equal to minus 3. Then we will have 1 is equal to a times, well, minus 3 plus 3 is equal to 0, plus b times, well, minus 3 plus 1 will be minus 2. So we're left with 1 is equal to minus 2b. And thus we can rearrange in order to arrive at b is equal to minus 1 half. Great, so now we have both a and we have b. We can use this and plug it back into our equation for the partial fractions in order to calculate the partial fraction version of 1 over r plus 1 times by r plus 3. Thus, when a is equal to a half, we will have 1 over 2 times r plus 1. And because b is minus a half, we'll have minus 1 over 2 times r plus 3. As such, our question now becomes the sum from 1 to n of 1 over 2 times r plus 1 minus 1 over 2 times r plus 3. Now, because this is just a sum, we can write down each of the terms of the sum separately. For example, when r is equal to 1, then 1 over 2 times r plus 1 will be equal to 1 over 2 times 2, which will just be a quarter. And on the right-hand side, we will have minus 1 over 2 times, well, 1 plus 3 will just be 4, so be minus 1 over 2 times 4, which is just minus 1/8. So we will have minus 1/8 on the right-hand side. We can do the same thing for r is equal to 2, r is equal to 3, r is equal to 4, and so on, until we get r is equal to n, which is the last term in our sequence. Now you can notice that some terms on the left-hand side will cancel with some previous terms on the right-hand side. For example, when r is equal to 3, the 1/8 cancels with the minus 1/8 when r is equal to 1. Similarly, when r is equal to 4, the 1/10 cancels with the minus 1/10 when r is equal to 2. And you can see that this pattern will repeat. Now if you look at the leftover terms here, on the top left we will have a quarter and a sixth, and on the bottom right we will have minus 1 over 14 and minus 1 over 16. But we need to be careful here, because minus 1 over 14 might be able to cancel with a positive 1 over 14 for r is equal to 6. And similarly, the minus 1 over 16 can cancel with a positive 1 over 16 when r is equal to 7. As such, we will need to determine when the sequence will stop producing terms that cancel. Now, if you continue this pattern on, you'll notice that when r is equal to n minus 1, the left-hand side will cancel, and when r is equal to n, the left-hand side will also cancel. But the last two terms on the right-hand side won't cancel, and this is because of the same reasoning applied over here. These terms aren't cancelled yet, because in order to be cancelled, there must be an r is equal to 6 and an r is equal to 7. Similarly, when r is equal to n minus 1, this term won't be cancelled, because in order for this term to be cancelled, there must be an r is equal to n minus 1 plus 2, which is r is equal to n plus 1. And similarly, when r is equal to n, this term won't get cancelled, because there must be an r is equal to n plus 2. However, because r is equal to n plus 1 and r is equal to n plus 2 is not in our sum, these terms are the remaining terms of our sequence. As such, we know that the leftover terms are when r is equal to n minus 1 and r is equal to n. Now when r is equal to n minus 1, these two terms will cancel, but these two terms won't, so we need to figure it out. Well, minus 1 over 2 times, if we look again at our equation, we will have 2 times by r plus 3. Well, when r is equal to n minus 1, n minus 1 plus 3 will just be n plus 2. And similarly, for r is equal to n, we will have minus 1 over 2 times n plus 3 plus n will just be n plus 3. Great, so now we have all of the remaining terms of our sum, which is a quarter, a sixth, minus 1 over 2 times n plus 2, and minus 1 over 2 times n plus 3. So the sum from r is equal to 1 to n of 1 over r plus 1 times by r plus 3 will just be equal to a quarter plus 1/6 minus 1 over 2 times n plus 2 minus 1 over 2 times n plus 3. Well, the equation we have over here is not quite the same as the equation that we have on top, because this is all in one fraction, and this is in multiple fractions. So let's try and simplify this all into one fraction. So we have a quarter plus 1/6 minus 1 over 2 times n plus 3 plus 1 over 2 times n plus 2 is equal to, well, a quarter plus a sixth will be 5 over 12, and we can simplify the right-hand side inside the bracket by multiplying the numerator and the denominator of 1 over 2 times n plus 3 by n plus 2, to be n plus 2 over 2 times n plus 3 multiplied by n plus 2, added to what we obtain when we multiply the numerator and the denominator of 1 over 2 times n plus 2 by n plus 3. So it will be n plus 3 over 2 times n plus 2 times n plus 3. So we get 5 over 12 minus 2n plus 5 all over 2 times n plus 3 times by n plus 2. And now we have to get the denominators of both of these fractions to be equal in order to simplify it further. So let's multiply 5 by n plus 3 times n plus 2 and put this all over 12 times n plus 3 times n plus 2. And you subtract 2n plus 5 times by 6 because you want to get the 12 on the denominator. Great, so now we have 5 times n plus 3 times by n plus 2 all over 12 times n plus 3 times n plus 2 minus 6 times 2n plus 5 all over 12 times n plus 3 times n plus 2. Let's expand out the brackets on the numerator and subtract them together. So we will have 5 times, well, n plus 3 times n plus 2 will be n squared plus 5n plus 6, and minus 6 times 2n plus 5 will be minus 12n minus 30. And this will all be over 12 times n plus 3 times n plus 2. We can simplify this even further by expanding out the 5 into the quadratic we have in the bracket. So we have 5n squared plus 25n plus 30 minus 12n minus 30 all over 12 times n plus 3 times n plus 2. And finally, we can simplify the numerator even further by noticing that there is a plus 30 over here and a minus 30 over here, and 25 minus 12 will be positive 13. So thus, this expression will be equal to 5n squared plus 13n all over 12 times n plus 3 times by n plus 2. And this expression will just be n times by 5n plus 13 all over 12 times n plus 3 times by n plus 2. Now, this is in the form that the question wanted us in, because the question wanted it in n times an plus b all over 12 times n plus 2 times n plus 3. And thus, we have solved the question. A is equal to 5 and b is equal to 13. Now that we have solved our question, let's find the marks. You get 1 mark for finding the value of a and the value of b. You get another mark for recognizing that this is a method of differences problem and applying it. You get yet another mark for writing out the remaining terms of the expression. You get another mark for writing it out in the simplified form where the denominator is equal to 12 times n plus 3 times n plus 2. and you get an accuracy mark at the end for arriving at the correct answer. In this question, we're asked to prove, by induction, that for all positive integers n, f of n, which is 2 to the power of 3n plus 1 plus 3 times 5 to the power of 2n plus 1, is divisible by 17. For all induction questions, you want to break down the problem into 4 main steps. These are, number 1, showing that it is true for n is equal to 1. Number 2, assuming that it is true for n is equal to k. Number 3, showing that if it is true for n is equal to k, it's also true for n is equal to k plus 1. And number 4, writing a conclusion. So first, let's carry out the first step, showing it's true for n is equal to 1. So we want to try for n is equal to 1. Well, when n is equal to 1, then f of 1 is equal to 2 to the power of 3 times 1 plus 1 is 2 to the power of 4, plus 3 times 5 to the power of 2 times 1 plus 1 will be 3, so it'll be 5 to the power of 3. And once you plug this into your calculator, you get the value of 391. And 391 is equal to 17 times 23. And thus it's true for n is equal to 1. Great, now that we've proved it's true for n is equal to 1, we need to assume that it's true for n is equal to k to carry out the induction. If it's true for n is equal to k, we should be able to write f of k as this. F of k is equal to 2 to the power of 3k plus 1 plus 3 times 5 to the power of 2k plus 1. And that should be equal to 17p, where p is an element of the whole numbers. Now all this is saying is that if we have n is equal to k, then this equation, 2 to the power of 3k plus 1 plus 3 times 5 to the power of 2k plus 1, will be divisible by 17. So now we need to carry out the third step of our induction. We need to show that it is also true for n is equal to k plus 1. Well, if we need to show that it is also true for n is equal to k plus 1, we need to show that f of k plus 1 is divisible by 17. So how do we go about doing this? Well, let's first substitute k plus 1 into our equation. So, f of k plus 1 will be equal to 2 times 3 times k plus 1 plus 1 plus 3 times by 5 to the power of 2 times k plus 1 plus 1. Let's expand the brackets to get this into a more simplified form. Well, this is equal to 2 to the power of 3 times k plus 1 will be 3k plus 3 plus 1 plus 3 times 5, 2 times k plus 1 will be 2k plus 2 plus 1. Now, in induction questions, you want to use the assumption that it is true for n is equal to k to show that when f is equal to k plus 1, the statement also holds true. So if we examine our assumption for f of k, we can see that f of k is equal to 2 to the power of 3k plus 1 plus 3 times 5 to the power of 2k plus 1. Now, if we look back to our equation that we have for f of k plus 1, we can see that there is a 2 to the power of 3k plus 1 plus 3 times 5 to the power of 2k plus 1. This is very similar to what we have for f of k. So how are we supposed to separate the plus 3 and the plus 2 inside the powers from the equation that we have for f of k plus 1? Well, if you remember indice laws, a to the power of b plus c will be equal to a to the power of b times by a to the power of c. Thus, 2 to the power of 3k plus 3 plus 1 will be equal to 2 to the power of 3k times by 2 to the power of 3. And similarly, 5 to the power of 2k plus 2 plus 1 will be 5 to the power of 2k plus 1 times 5 to the power of 2. Fantastic! So now we have something that is very similar to what we have for f of k, with an extra 2 to the power of 3 and an extra 5 to the power of 2. Well, we can simplify this expression a bit more, because this will be equal to 2 to the power of 3k plus 1 times 2 to the power of 3 will be 8, so it will be times by 8, plus 3 times by 5 to the power of 2k plus 1, times by 5 squared will be 25, so it will be times by 25. Now, one way to get f of k from f of k plus 1, as we've simplified over here, is to notice that 25 can be split into 8 plus 17. And thus, the right-hand side can actually be written as 2 to the power of 3k plus 1 times 8 plus 3 times 5 to the power of 2k plus 1 times by 8 plus 17. And thus, you can rewrite this entire expression as 2 to the power of 3k plus 1 times by 8 plus 3 times 5 to the power of 2k plus 1 times by 8 plus 3 times 5 to the power of 2k plus 1 times by 17. And thus you can notice that there is an 8 times 2 to the power of 3k plus 1 and an 8 times 3 times 5 to the power of 2k plus 1. And as they both share a factor of 8, you can factorize that out to give you 8 times 2 to the power of 3k plus 1 plus 3 times 5 to the power of 2k plus 1 plus 17 times by 3 times 5 to the power of 2k plus 1. And you can see that this part inside the brackets is actually what we have for f of k, 2 to the power of 3k plus 1 plus 3 times 5 to the power of 2k plus 1. And thus we can actually rewrite this expression as 8 times f of k plus 17 times 3 times 5 to the power of 2k plus 1. And look at what we found. There is an 8 times f of k plus 17 times 3 times 5 to the power of 2k plus 1. This is divisible by 17. But is this divisible by 17? Well, if we look back at our original equation, we have f of k is equal to 17p, where p is an element of the whole numbers. And thus, f of k must be divisible by 17, because we assume that in our assumption statement, f of k is divisible by 17. So that means that 8 times 17p plus 17 times 3 times 5 to the power of 2k plus 1 will be equal to f of k plus 1. If our assumption statement that f of k is divisible by 17 holds true. And thus we can factor out a 17 from this entire expression, as this implies that f of k plus 1 is equal to 17 times by 8p plus 3 times by 5 to the power of 2k plus 1. And thus f of k plus 1 is divisible by 17. Therefore, what we need to do now is look back at our steps. Step 3 was to show that it is also true for n is equal to k plus 1. Well, indeed we have found that f of k plus 1 is divisible by 17. And thus we need to write a conclusion. Well, our conclusion will be as such. We have proven that f of n is divisible by 17 for n is equal to 1. So we have proven the statement is true for n is equal to 1. We have shown that when we assume that the statement is true for n is equal to k, it's also true for n is equal to k plus 1. And thus, we know that by induction, if it's assumed true for n is equal to k, and it's also true for n is equal to k plus 1, it must be true for all positive values of n. The important key words to note here is that we have proven true for n is equal to 1, we have shown that when the statement is assumed true for n is equal to k, it also is true for n is equal to k plus 1, and thus by induction is true for all positive n that's an integer. Thus we have proven our statement above. We have proven by induction that for all positive integers n, f of n is divisible by 17. Now that we have solved our question, let's find out where the marks are. We get 1 mark for showing that the statement is true for n is equal to 1. We get another mark for assuming true for n is equal to k. We get another mark for writing out f of k in this form, and an accuracy mark for arriving at this solution in which we can write f of k plus 1 using f of k. We thus get an accuracy mark by showing that f of k plus 1 is equal to 17 times by 8p plus 3 times 5 to the power of 2k plus 1. And we get a method mark for writing our concluding statement. In this question, we're given an equation f of z is equal to z to the power 4 plus az cubed plus 6z squared plus bz plus 65, where a and b are real constants. Given that z is equal to 3 plus 2i is the root of the equation f of z is equal to 0, we need to show the roots of f of z equal to 0 on an Argand diagram. Now the first thing to notice about this question is that one of the roots, 3 plus 2i, is a complex root. And if you have a complex root, there must always be a conjugate pair. So we know that z is equal to 3 plus 2i is one root, but we also know that z is equal to 3 minus 2i must also be a root, because we know that every single complex conjugate must have a conjugate pair. And thus we know that two linear factors of f of z will be z minus 3 plus 2i and z minus 3 minus 2i. Now we can expand these brackets out. Z multiplied by z is equal to z squared, so it will be z squared, and minus 3 plus 2i times z will be minus z times 3 plus 2i, and similarly z times minus 3 minus 2i will be minus z times 3 minus 2i, and finally minus 3 plus 2i times minus 3 minus 2i will be the same as 3 plus 2i times 3 minus 2i. And if you notice here, this would be a difference of two squares. So it would be 3 squared, which would be 9, minus, well, 2i all squared would be minus 4. So it would be 9 minus minus 4, and this would be 13. So you add 13 on the end of this. Great, so now we know a quadratic factor of f of z. We can simplify this a bit further, as we can rewrite this as z squared minus, well, it will be minus z times 3 plus 2i plus 3 minus 2i, which would just be 6 plus 13. So now we know that there is a quadratic factor of z squared minus 6z plus 13 of f of z. Now, in order to get the quartic polynomial, we must multiply our quadratic factor with another quadratic. Thus, f of z can be written as z squared minus 6z plus 13 multiplied by alpha z squared plus beta z plus gamma, where alpha, beta and gamma are some constants that we don't know yet. Now this is just a formula for a general quadratic, so this is just saying that our quadratic that we found earlier multiplied by some other unknown quadratic right now is equal to our quartic f of z. Well, we can find out the values of alpha, beta and gamma by using some inspection. So, for example, 65 over here, the constant 65, can only be formed if we have two constants multiplied by each other. In this case, it will be 13 gamma is equal to 65, and thus gamma has to be 65 divided by 13, which would just be 5. Similarly, in order to get alpha, we can see that in order to get the coefficient of z to the power 4 of our equation, which is just 1, we need to multiply in these two quadratic factors a z squared term multiplied by another z squared term. So z to the power 4 is equal to alpha z squared times z squared, and thus alpha will just be 1 because you can divide both sides by z to the power 4. So now we know the value of alpha and gamma, we can rewrite f of z as such. F of z is equal to z squared minus 6z plus 13 multiplied by, well, alpha z squared will just be z squared plus beta z, we still don't know the value of beta, plus gamma, which is 5, which we found over here. So now that we know the values of alpha, beta and gamma, what we can now do is find the value of beta. Well, in order to find the value of beta, we need to use this fact. 6 is the coefficient of z squared for f of z. So we know that 6 is the coefficient of z squared of f of z, and thus we can use some more inspection to find out the value of beta. Well, how do we get z squared from these two quadratics? If you were to expand out these quadratics fully, which we don't want to do by the way because that would take too much time. Well, if we wanted to get a z squared from our two quadratic factors we have here, we'll first multiply z squared by 5 and minus 6z with plus beta z and 13 with z squared. These are the only ways that you can get a z squared term, because if you multiply any other way, it will not produce a z squared term. As such, we know that the z squared terms are 5z squared from this multiplication minus 6 beta z squared from this multiplication and 13z squared from this multiplication. And we know that this has to be equal to 16z squared. Now let's divide all of this by z squared. Now we can just solve for beta. So 5 plus 13 will be 8, and 8 minus 6 will be 12. So 12 is equal to 6 beta, and thus beta is equal to 2. Great, so now we know alpha, beta, and gamma, so we can rewrite f of z completely as z squared minus 6z plus 13 multiplied by z squared plus 2z plus 5. Well, we want to find out the values for f of z is equal to 0, and we know that from this factor we have z is equal to 3 plus or minus 2i. Now we need to find out the factors of this quadratic. Well, one way we can do this is by completing the square, but obviously you can do it also by using the quadratic formula or some other method that you have been taught. So I'm going to do it by completing the square. So by completing the square, we have that z plus 1 all squared minus 1 plus 5 is equal to 0, and thus z plus 1 all squared is equal to, well, minus 1 plus 5 will just be positive 4, so we bring that over to the other side, which will leave us with minus 4, and then we can square root both sides to form z plus 1 is equal to plus or minus, well, the square root of minus 4 will just be 2i, so it'll be plus or minus 2i, and then we solve, so z is equal to minus 1 plus or minus 2i. There, now we have our value for z. Z is equal to minus 1 plus or minus 2i, and thus we have all of our roots of f of z. Z is equal to 3 plus 2i, z is equal to 3 minus 2i, z is equal to minus 1 plus 2i, and z is equal to minus 1 minus 2i. Notice how every single complex root has a complex conjugate. So minus 1 plus 2i here, and minus 1 minus 2i here are complex conjugates. You have to remember that every single complex root has a complex conjugate. Therefore, we can now sketch all of these points on our Argand diagram. So let's write our Argand diagram over here. So we have our imaginary axis and our real axis. Our imaginary axis has to have labeled axis names, and the real axis also has a labeled axis name. Now our roots are 3 plus or minus 2i, and 1 plus or minus 2i, or minus 1 plus or minus 2i. So let's sketch our first complex conjugates. So we have 3 on our real axis, and we plus 2i, so this would be 3 plus 2i. We label this as 2i, and this would be minus 2i, and then it will also be 3 minus 2i as one of our other complex conjugates, and we draw arrows to them as such. Similarly, for our other roots, we have minus 1 over here, and it'll be minus 1 plus 2i, and minus 1 minus 2i. So we will sketch our arrows as such, making sure that they go through the origin. Must go through the origin. And there we have our completed Argand diagram of the sketch. This question was 9 marks, so let's find out where the marks are. You get 1 mark for noticing, because of complex conjugates always having a conjugate root, that 3 minus 2i is also a root. You get another mark for writing out the factors of f of z in this linear form. You get yet another mark for expanding it out in this form. You get another mark for writing out f of z in this form, where you know alpha and gamma but not beta. You get another mark for finding the value of beta and thus writing it out fully in this form. You get 2 more marks for finding out the value of z, and you get a method mark and an accuracy mark for writing out the Argand diagram at the end. In this question, we're given a polar curve C, and we're told that it has the polar equation r is equal to 4 plus cos 2 theta, where theta is between 0 and pi over 2. At the point A on C, the value of r is 9 over 2. This means that the length OA is equal to 9 over 2, so we can label this on our diagram. We're also given that n lies on the initial line and an is perpendicular to the initial line. Well, if this is n and this is an, it means that this is a right angle. The finite region R, shown shaded in figure 1, this is R, is bounded by the curve C, the initial line and the line an. We want to find the exact area of the shaded region of R, giving our answer in the form p pi plus q root 3, where p and q are rational numbers to be found. So the first thing that should come to mind when reading this question is that we must use in some way or form polar integration, as this is the only way that we could possibly find the area beneath a polar curve. Well, if we were to integrate this polar curve between 0 and whatever this angle theta is, then we would get this entire area, but we only want the region R. So we'll need to find the area of this triangle, OAN, here. Let's call this triangle S. Okay, great, so now we have all the information needed to answer our question. So the first thing that we should do is use this information here, that the length of R at the point A on C is 9/2. Well, if R is equal to 9/2, then we can plug this into our polar equation in order to find the value of theta. So 9/2 is equal to, well, the equation of R is 4 plus cos 2 theta, so it'll be 9/2 is equal to 4 plus cos 2 theta, and thus a half is equal to cos 2 theta, and hence 2 theta is equal to pi over 3, and thus theta is equal to pi over 6. Now we can label this value of theta in our graph, so instead of theta we can write this as pi over 6, and now that we have the angle, we can find out the sides of ON and AN, and thus calculate the area of our triangle later on. However, first let's integrate the entire polar expression. Well, to integrate a polar equation, you must use the formula, a half times the integral between alpha and beta of R, all squared, with respect to theta. Now we can use this in order to integrate our polar curve, as our lower limit, alpha, will be equal to 0, and our upper limit, beta, will be equal to pi over 6. This is because, once again, we are integrating between 0 and whatever this angle is. Well, we found this angle, it's pi over 6. So let's plug it into our formula. So the area of S plus R will be the integral between theta is equal to 0 and theta is equal to pi over 6 of R squared. Great, so now we can integrate this integral in order to find out the area of S plus R. Well, the first thing we can do is expand out this bracket. Here I'm using the grid in order to expand out the bracket, but you can expand it out any other way. Now let's look at the terms that we need to integrate. We can integrate 16 pretty easily, as the integral of 16 will just be 16 theta. We can also integrate cos 2 theta pretty easily, because this is just a trigonometric integral. But how are we supposed to integrate cos squared 2 theta? Well, we can recall, using double angle formulae, that cos 2a is equal to 2 cos squared a minus 1. And thus, cos 2a plus 1 all over 2 is equal to cos squared a. Now, given this, if we let a is equal to 2 theta, we can find cos squared 2 theta in terms of cos 4 theta, as cos 4 theta plus 1 all over 2 will be equal to cos squared 2 theta. And thus we have it, an expression for cos squared 2 theta in terms of cos 4 theta. We can integrate this because we know the integral of cos 4 theta. If we plug in our value of cos squared 2 theta into our original equation, we get a half times the integral between 0 and pi over 6 of 16 plus 8 cos 2 theta plus cos 4 theta plus 1 all over 2. Well, we have the constant which stays at the front over here, multiplied by, well, the integral of 16 will be 16 theta plus 8 times, well, the integral of cos 2 theta will be sine 2 theta over 2. The integral of cos 4 theta will be sine 4 theta all over 4, and thus that divided by 2 will just be sine 4 theta all over 8. The integral of a half will be a half theta. And this is between pi over 6 and 0. So now let's simplify this expression by plugging in our values of 0 and pi over 6. So let's plug in our pi over 6 first. So we have a half times by, well, 16 times by pi over 6 will be 16 pi over 6. So it'll be 16 pi over 6 plus 8 times by, well, sine 2 times pi over 6 will be sine of pi over 3. And sine of pi over 3 will be root 3 over 2. And thus root 3 over 2 all over 2 will be root 3 over 4. So 8 times root 3 over 4 plus sine of 4 theta, well, sine of pi over 6 multiplied by 4 will be equal to sine of 2 pi over 3. And that will be equal to root 3 over 2. And thus we will have root 3 over 2 divided by 8. So be plus 1 over 8 times root 3 over 2 plus, and theta over 2, when theta is equal to pi over 6, will be pi over 12. So plus pi over 12. And you'd want to subtract the integral when the lower limit is equal to 0. But notice that when theta is equal to 0, all the terms over here will be equal to 0. 16 times 0 is 0, sine of 2 times 0 is equal to 0, sine of 4 times 0 is equal to 0, and 0 over 2 will just be 0. So we're just left with this that we need to simplify, and thus the area beneath the polar curve will be equal to 1/2 times, well, let's group the pi terms together. So 16 pi over 6 plus pi over 12 will be equal to 11 pi over 4. Plus, well, we can also group the root 3 terms together. So 8 times root 3 over 4 plus 1/8 times root 3 over 2 will be 33 root 3 all over 16. And we can simplify this even further because this is all halved, so it'll just be 11 pi over 8 plus 33 root 3 all over 32. Great, so now we know the area of S plus R under the polar curve between 0 and pi over 6. But now we need to get R by itself, and we do this by subtracting S from S plus R. So how do you find the area of S? Well, we know that the length of ON can be calculated by doing 9 over 2 times by cos pi over 6. And the length of AN can be calculated by doing 9 over 2 times sine of pi over 6. And thus the area of the entire triangle can be calculated by doing 1/2 times by 9 over 2 times by cos pi over 6 times by 9 over 2 times by sine pi over 6. So that's the area of OAN. So let's move our workings back down to our question. So thus the area of the triangle OAN will be 1/2 times 9 over 2 squared times by cos pi over 6 times by sine pi over 6. And we can put this into our calculator to calculate the value 81 root 3 all over 32. Great, now we know the area of S, and thus the area of R, if we recall our curve, which looks something like this. This is R, and this is S. Well, the area of R will then be 11 pi over 8 plus 33 root 3 all over 32. Subtract 81 root 3 over 32, as 81 root 3 over 32 will be equal to S. And this value will just be 11 pi over 8 minus 3 root 3 all over 2, where, if we recall in our question, we need to find P. Well, P is equal to 11 over 8, and Q is equal to minus 3 over 2. Now that we have solved the question, let's find out where the marks are. You get a method and an accuracy mark for finding out the value of theta, so you get 2 marks over here. You get 1 mark for writing out the integral of S plus R, so you get another mark over here. You get 1 mark for using the double angle formula in order to find out an equation for the integral in terms of cos 4 theta, so you get 1 mark over here. You get another mark for actually integrating. And you get another mark for substituting our value of pi over 6, so this mark over here. You get yet another mark for calculating the area of the triangle. You get a method mark for subtracting the area of the triangle from the area of S plus R. And you get a final accuracy mark for arriving at the correct conclusion. It tells us that a pond initially contains 1,000 litres of unpolluted water. The pond is leaking at a constant rate of 20 litres per day. It is expected that contaminated water flows into the pond at a constant rate of 25 litres per day, and that the contaminated water contains 2 grams of pollutant in every litre of water. It is assumed that the pollutant instantly dissolves throughout the pond upon entry. Given that there are X grams of the pollutant after T days, we need to A. Show that the situation can be modelled by the differential equation dx by dt is equal to 50 minus 4x all over 200 plus t. So for part A, we want to show that the situation can be modelled by the differential equation dx by dt is equal to 50 minus 4x over 200 plus t. So our pond initially contains 1,000 litres of unpolluted water. Our pond leaks water at a constant rate of 20 litres per day, but water also flows into the pond at a constant rate of 25 litres per day. We know that with this 25 litres of water flowing in per day, contaminated water also flows in with 2 grams of pollutant in every litre of water. Well, now that we have this information in this condensed form, we can use it to answer part A. Well, we know that the rate of flow in is 25 litres per day and the rate of flow out is 20 litres per day. So thus, the total rate of flow into the pond will be 5 litres per day. This is because per day there are 25 litres flowing in, but also there are 20 litres flowing out. So the net change will be just 5 litres per day flowing into the pond. Thus, we know that the total amount of water in the pond after T days will be the initial volume of water, which is 1,000 litres, plus the total flow into the pond per day multiplied by the number of days that have passed. So the total volume of water will be 1,000 plus 5t litres after t days. Well, what else can we pick apart from this question? Well, dx by dt is the rate of change of pollutant in the pond after t days. Well, using this definition, we know that the rate of change of pollutant in the pond can be represented by the rate of pollutant into the pond subtracted by the rate of pollutant out of the pond. Well, in order to calculate the rate of pollutant into our pond, we need to use this information, that the rate of flow in is 25 litres per day and that 2 grams of pollutant flows in with every litre of water. Well, if 2 grams of pollutant flows in with every litre of water, and there are 25 litres of water that are flowing in per day, then the rate of pollutant in will be 25 litres per day, multiplied by 2 grams per litre, and this gives you 50 grams per day, which is the rate of pollutant into the pond. Well, in order to calculate the rate of pollutant out, we need to find out how many grams of pollutant is in every litre of water. Well, in order to do that, we need to use the information that there are X grams of pollutant after T days and that the total volume of water is 1,000 plus 5T. Well, if there are X grams of pollutant after T days and the total volume of water after T days is 1,000 plus 5T, then at any moment in time, there are X over 1,000 plus 5T grams of pollutant per every litre. This is because the total amount of pollutant in the pond is X grams and the total volume of the pond is 1,000 plus 5T. So every litre of water must have X over 1,000 plus 5T grams per litre of water in the pond. You can notice that this expression varies with respect to T, which makes sense because the amount of pollutant per litre of pond will change as more pollutant is added to the pond. So thus the rate of pollutant out will be, well, we have the rate of flow out, which is 20 litres per day, will be 20 litres per day, multiplied by X over 1,000 plus 5T grams per litre. So X over 1,000 plus 5T grams per litre. So now we have the rate of pollutant in and the rate of pollutant out. So we can substitute this into our expression for dx by dt to form dx by dt is equal to, well, 25 multiplied by 2 would be 50. So we have 50 subtract, 20 times by x over 1,000 plus 5t will be 20x over 1,000 plus 5t. But we can divide both the numerator and the denominator by 5 to just give you 4x over 200 plus t. And this expression is the same as the expression we want in part A, and thus we have shown the equation. So for part A, you get 1 mark for noticing that the total volume of water after T days is 1000 plus 5T liters after T days. You get another mark for noticing that the rate of pollutant in will be 25 liters per day multiplied by 2 grams per liter. You get another mark for noticing that the rate of pollutant out will be 20 liters per day multiplied by x over 1000 plus 5T grams per liter. And you get your final accuracy mark for arriving at the correct show that conclusion. For part B, we want to hence find the number of grams of pollutant in the pond after 8 days. Well, we know that we have the differential equation. dx by dt is equal to 50 minus 4x over 200 plus t. Now, if we want to find the number of grams of pollutant in the pond after 8 days, we first need to remember that the grams of pollutant is represented by x, and the number of days since the start of the experiment is represented by t. And thus, in order to find the number of grams of pollutant in the pond after 8 days, we first need to find an equation in terms of x using our differential equation over here. Well, we can first note that this equation is a first-order differential equation, so let's try moving all of the terms within x to one side. So we have dx by dt plus 4 over 200 plus t multiplied by x is equal to 50. And you can see here that this is a first-order differential equation as it has a dx by dt and an x multiplied by a function of t. Well, in order to solve a differential equation, in order to get something in terms of x, we need to use the integrating factor. So for any differential equation in the form dx by dt plus pt multiplied by x is equal to qt, the integrating factor it is e to the power of the integral of pt with respect to t. Well, thus, in this case, if we use the integrating factor in our equation over here, we can note that the integrating factor, it, is equal to e to the power of, well, pt in this case would be 4 over 200 plus t, it would be 4 over 200 plus t, or the integral of 4 over 200 plus t, with respect to t. And thus, the integrating factor will be, well, the integral of 4 over 200 plus t will be 4 ln 200 plus t. So the integrating factor can be rewritten as e to the power of 4 ln 200 plus t. And you can use the laws of logs in order to take this 4 inside the ln, forming e to the power of ln 200 plus t all to the power 4. The e and the ln will cancel to just give you 200 plus t all to the power 4 as your integrating factor. Now we can use the integrating factor to note that d by dt of 200 plus t, which is our integrating factor, all to the power 4 multiplied by x is equal to the constant on the right hand side, which is 50, multiplied by our integrating factor again, which is 200 plus t to the power 4. We can now integrate both sides with respect to t in order to find something in terms of x. So if we integrate both sides in terms of t, we have 200 plus t to the power 4 multiplied by x is equal to the integral of 50 multiplied by 200 plus t all to the power 4 with respect to t. This will give you 200 plus t to the power 4 multiplied by x is equal to, well, if you integrate the expression inside the integral, you will obtain 10 multiplied by 200 plus t all to the power 5 plus c, which is the constant because we don't have limits on this integral. Now we can divide both sides by 200 plus t to the power of 4 because 200 plus t can never be 0, as t has to be a positive number. So we have x is equal to 10 times 200 plus t plus c all over 200 plus t to the power 4. Now we want to find the number of grams of the pollutant in the pond after 8 days. So in order to do this, we need to find the constant c. Well, our question tells us our pond initially contains 1000 liters of unpolluted water. And thus, when t is equal to 0, as shown by our initially keyword, our pond contains 1000 litres of unpolluted water, so x is equal to 0, as the grams of pollutant in the pond is equal to 0 when t is equal to 0. So let's substitute this into our equation. So we have 0 is equal to 10 times by 200 plus 0 plus c over 200 plus 0 all to the power 4. We can rearrange this a bit to get c is equal to minus 10 times 200 all multiplied by 200 to the power 4, and we can plug this into our calculator to give you c is equal to minus 3.2 times 10 to the 12. Now if c is equal to minus 3.2 times 10 to the power 12, then our differential equation looks like x is equal to 10 multiplied by 200 plus t minus 3.2 times 10 to the 12 all over 200 plus t to the power 4. And hence we can find the grams of pollutant in the pond after 8 days, as after 8 days t is equal to 8, and we can plug in t is equal to 8 into our equation to give you x is equal to 10 times 200 plus 8 minus 3.2 times 10 to the 12 all over 200 plus 8 to the power 4. And this will give you approximately 370 grams of pollutant in the pond after 8 days, and that's our answer. For part B, you get a method mark for calculating the integrating factor and by putting it in this form. You get another mark for actually integrating the right-hand side. You get yet another mark for using our initial conditions in order to calculate the value of c. You get another mark for plugging in our value of 8 into our equation, and you get a final accuracy mark for arriving at the correct answer. So for part C, we need to explain how this model could be refined. Well, if we look back at our model, we can see that it is assumed that the pond leaks at a constant rate of 20 litres per day, and it also flows into the pond at a constant rate of 25 litres per day. Well, we can't really say much about the rate of flow into the pond, but is it really suitable to say that the pond will leak at a constant rate of 20 litres per day? Well, that might not be the case, and as such, one improvement could be that the rate of leaking could be made to vary with the volume of water in the pond. This question is only 1 mark, so you'll get 1 mark for stating this point, but there is also another point that would be eligible for a mark. We assume here that the pollutant instantly dissolves throughout the pond upon entry. Now the keyword instantly here suggests that as soon as the pollutant enters the pond, the entirety of the pond has the same concentration of pollutant throughout the pond. Well, this in real life will probably not make any sense, especially if the pond is super massive. And thus, another refinement we can make is that the model should take into account the fact that the pollutant does not dissolve throughout the pond upon entry. So, because this question is only 1 mark, you will only get 1 mark for stating any of these points, but either of these points are valid. So you get 1 mark for stating the first point, or you can get 1 mark for stating the second point. Either or will work. In this question, we're given that f of x is equal to x plus 2 over x squared plus 9. In part A of this question, we're asked to show that the integral of f of x with respect to x is equal to a ln x squared plus 9 plus b arctan x over 3 plus c, where c is an arbitrary constant and a and b are constants to be found. Well, let's first write out the integral in its full form. We have the integral of f of x, which is x plus 2 all over x squared plus 9. Now, how do we go about integrating this? Well, at first glance, it may seem that it might have something to do with ln integrals, because there's an x squared term at the bottom in the denominator over here, and an x term at the top in the numerator over here. However, ln integrals only work if the derivative of the denominator is equal to the numerator, or a multiple of it. However, that's not true in this case, because the derivative of x squared plus 9 is equal to 2x, but the numerator has an x plus 2. Well, one way that we can rewrite this fraction is by separating it into x over x squared plus 9 plus 2 over x squared plus 9 with respect to x. Now, if we split it up like this, we can notice that this fraction on the left-hand side is just a ln integral. In fact, if we just integrate the left-hand side by itself, this will be equal to a half ln of x squared plus 9. Now let's integrate the right-hand side. Now, if you recall from your formula book, the right-hand side looks like an arctan integral. In fact, 1 over a squared plus x squared is equal to 1 over a times arctan x over a. Now, this is very, very similar to what we have over here. In fact, in this case, a is equal to 3. So we can plug in a is equal to 3 into our equation and remember the 2 as the scalar constant that our integral is multiplied by to give you 2 over 3 arctan x over 3. And this is all added to c because there are no limits to this equation. And thus we have shown what we have above over here, that f of x, or the integral of f of x, is equal to a ln x squared plus 9 plus b arctan x over 3 plus c, where a is equal to a half and b is equal to 2 over 3. Now for part B, we need to use this information in part A in order to show that the mean value of f of x over the interval of 0 to 3, well, we can rewrite this interval as 0 is less than or equal to x is less than or equal to 3, is 1 over 6 ln 2 plus 1 over 18 pi. Well, you can recall that the mean value of a function can be calculated by doing 1 over b minus a between the interval of a and b of f of x dx, where a and b are intervals in which the mean value is calculated over. Now in this case, our interval is between 0 and 3. Thus, we can plug in b is equal to 3, which is the upper limit, and a is equal to 0, which is the lower limit, into our equation to receive 1 over 3 minus 0 times by the integral between 0 and 3 of f of x with respect to x. Now we can use what we found in part A in order to calculate the value of the mean function, as we know that the integral of f of x would just be a half ln x squared plus 9 plus 2 over 3 arctan x over 3. So let's substitute this into the integral we have over here, remembering that there are now limits. So we have 1 over 3 times by a half ln x squared plus 9 plus 2 over 3 arctan x over 3, and this is between 3 and 0. Now let's put limits inside of our brackets. So we have a third times by, well, we have a half ln, or 3 squared plus 9 will just be 18. So a half ln 18 plus 2 over 3 times by arctan, well, 3 over 3 would just be 1, so we arctan 1 minus, well, a half ln 0 plus 9 would be a half ln 9, plus 2 over 3 arctan 0 over 3, which would be arctan 0. Well, arctan 0 will just be 0, so it would just be plus 0. And we can write this as a third times by a half ln 18 plus 2 over 3, well, arctan of 1 would be pi over 4, so this would be pi over 4, minus a half ln 9. Now, if we look back to the form that we want our equation in, we want all of the ln values grouped together, and we want a ln 2. We also want something in terms of pi. Well, if we scroll back down, so this is equal to, well, if we bring the third inside the brackets, we have a third times by a half would be a sixth ln 18 plus, well, a third times 2 over 3 times by pi over 4 will be pi over 18 minus, and once again, a third times a half will be minus 1 over 6 ln 9. Now, if we look back at our question, we have a ln 18 and a ln 9 over here, but our question asks for a ln 2. We have a pi over 18, so let's leave our pi over 18. Well, how will we get ln 2 out of ln 18 and ln 9? Well, you can notice that 18 is equal to 9 times 2. And thus, using our laws of logs, we can split ln 18 into 1 over 6 ln 9 plus 1 over 6 ln 2. as ln 18 will be equal to ln 9 plus ln 2. As such, we can plus pi over 18 at the end, and minus 1 over 6 ln 9 at the end as well. And we can see the 1 over 6 ln 9 and the minus 1 over 6 ln 9 cancels, leaving us just with 1 over 6 times by ln 2 plus pi over 18, which is what we wanted in the question above. So we have proven it. For part C, we want to use our answer to part B to find the mean value over the integral of x between 0 and 3 of f of x plus ln k. Well, the mean value of f of x plus ln k will just be written as 1 over b minus a of 0 and 3 of f of x plus ln k with respect to x. So this is equal to 1 over 3 times by the integral of 0 to 3 of f of x with respect to x plus 1 over 3 times the integral between 0 and 3 of ln k with respect to x. Well, we know this. This is just 1 over 6 times ln 2 plus pi over 18. Now let's calculate the value of this. Well, if we integrate this expression, ln k will just be a constant because there is no x term in this function. So we have 1 over 3 times by x ln k between 0 and 3. And that's going to be equal to 1 over 6 ln 2 plus pi over 18 plus 1 over 3 times by, well, 3 times ln k will just be 3 ln k, and 0 times ln k will be 0, so let's leave this as 3 ln k. So we have 1 over 6 times ln 2 plus pi over 18 plus, well, a third times 3 will just be 1, so this would just be ln k. Now, the question wants it in the form p plus 1 over 6 ln q, where p and q are constants and q is in terms of k. Well, if q is in terms of k, it means that we need to bring all of the ln's into one ln function. So this will be equal to, well, ln k can be rewritten as 1 over 6 times ln k to the power of 6. As if we recall our laws of logs, this would just be equal to 6 times 1 over 6 ln k. So this is equal to 1 over 6 times ln 2k to the power of 6 plus pi over 18, which is what we wanted to show in our question above. Hence, we have also shown part C. Now that we've answered the question, let's find out where the marks are. For part A, you get 1 mark for identifying that x plus 2 over x squared plus 9 is equal to x over x squared plus 9 plus 2 over x squared plus 9. You get another mark for integrating the first fraction, so x over x squared plus 9 is equal to a half ln x squared plus 9. And you get another mark for integrating the second fraction using the information that you're given in the formula book. So 2 over x squared plus 9 is equal to 2 over 3 arctan x over 3. You get a final accuracy mark for arriving at the correct answer. For part B, you get 1 mark for using the information that you were given in part A to obtain this integral in which you substitute in the limits. You get another mark for identifying how you can pull out a ln 2 from the ln's. And you get a final mark for arriving at the correct conclusion. For part C, you get 1 mark for identifying that the mean value of f of x plus ln k be 1 over 6 ln 2 plus pi over 18 plus ln k. And you get another final accuracy mark for arriving at the correct conclusion. In this question, we're given an image of a gold pendant which has height 2 centimeters. The pendant is modeled by a solid of revolution of a curve C about the y-axis. The curve C has parametric equations. X is equal to cos theta plus a half sine 2 theta, and y is equal to minus 1 plus sine of theta, where theta is between 0 and 2 pi. We want to show that a Cartesian equation of the curve C is x squared is equal to minus y to the power of 4 plus 2y to the power of 3 in part A. So part A is asking us to, using these parametric equations in terms of theta, find out an equation in terms of x and y only. So first, let's work with our x equation, where we know that x is equal to cos theta plus a half sine 2 theta. Well, our y equation has something in terms of sine theta, and thus let's try converting our sine 2 theta into something in terms of cos theta and sine theta. We know that sine of 2 theta is equal to 2 sine theta cos theta using our double angle formula identities, and thus x can be written as cos theta plus a half times by 2 sine theta cos theta. And this can be rewritten as x is equal to cos theta plus, well, a half times 2 will be 1, so it'll just be sine theta cos theta. Now we can notice that we can factorize out a cos theta from this expression to give you x is equal to cos theta multiplied by 1 plus sine theta. Now you can see there is a 1 plus sine theta over here, and there is also a minus 1 plus sine theta over here in our parametric equation for y. Well, we can multiply both sides of this equation by minus 1 to form minus y is equal to 1 plus sine theta. And hence, because we know 1 plus sine theta is equal to minus y, we can plug in minus y into our equation for x that we found over here. So x is equal to cos theta multiplied by minus y, as 1 plus sine theta is equal to minus y. Well, there's no cos theta we can easily extract from our y equation. However, we can note that cos squared theta plus sine squared theta is equal to 1. Now, using this identity that cos squared theta plus sine squared theta is equal to 1, we can rearrange to get a value of cos theta by itself. So cos squared theta is equal to 1 minus sine squared theta. So cos squared theta is equal to 1 minus sine squared theta, and hence cos theta is equal to plus or minus root 1 minus sine squared theta. Well, we can extract a sine theta from this equation, as sine theta is equal to, well, we can subtract 1 from both sides of this equation to form sine theta is equal to minus 1 minus y, which is equal to minus 1 plus y. And thus we can substitute this rearrangement into what we have over here to give you cos theta is equal to plus or minus root of 1 minus 1 plus y all squared, as minus 1 plus y is equal to sine theta, and thus we substitute minus 1 plus y into sine theta over here. Well, we can simplify this expression a bit more, as this will mean that cos theta is equal to plus or minus root 1, well, minus 1 plus y all squared will just be equal to 1 plus y all squared. And 1 plus y all squared will be 1 plus 2y plus y squared. We can simplify this once more to give you cos theta is equal to plus or minus root of, well, 1 minus 1 would be equal to 0, so it will just be 2y plus y squared multiplied by minus 1. It would be minus 2y plus y squared. Now we can plug this expression in terms of y for cos theta into our original to give you x is equal to plus or minus root minus 2y plus y squared times by minus y. Now we have something only in terms of x and y, which is what a Cartesian equation is. Well, if we look at our show that problem, it wants something in terms of x squared, and right now we have an x. So let's try squaring both the left-hand side and the right-hand side. So x squared is equal to, now if we square the right-hand side, plus or minus root minus 2y plus y squared all squared will just give you the thing that's inside of the root, which is minus 2y plus y squared. It does not matter if it's the positive or negative square root, because if you square something, you're always going to get the positive term. So you're always going to get this term inside of the root in this case. Minus y all squared will just be y squared. So you're left with y squared multiplied by minus 2y plus y squared. Now we can multiply this bracket by y squared to give you x squared is equal to minus, well, 2y times y squared would be 2y cubed, and y squared times y squared would be y to the power 4. And if we look back to our equation, this is exactly the same as what we have over here, which is equal to minus y to the power 4 plus 2y cubed. And this expression over here is exactly the same as what we have in our show that for part A, and thus we have our answer. Now that we've answered part A, let's find out where the marks are. In part A, you get 1 mark for noticing that x is equal to minus y times by cos theta. You get another mark for noticing that sine of theta is equal to minus y plus 1, and thus substituting it in to our cos theta is equal to plus or minus root 1 minus sine squared theta to give you this simplified expression for cos theta. You get another mark for substituting this value of cos theta into the equation we have over here and squaring both sides in order to get you this unsimplified expression over here. And you get a final accuracy mark for deriving the correct answer. For part B of the question, we want to use the model to find the volume of the pendant in centimeters cubed. Well, we know that the Cartesian equation for the curve C is x squared is equal to minus y to the power 4 plus 2y to the power 3. We also know that we're rotating this droplet around the y-axis. So, because this droplet is symmetrical at this point, let's assume that this part is the y-axis. Now, it may be tempting to label this as y is equal to 0 and label this as y is equal to 2 because the height is 2 centimeters. But you have to be careful here because we don't actually know whether at this point y is equal to 0 and at this point y is equal to 2. So we need to find the value of y at this point, which is the base, and this point, which is the height, respectively, so that we can use our volume of revolutions formula, which is pi times the integral between a to b of x squared with respect to y. And this volume of revolutions formula applies to revolutions around the y-axis, where a is the lower limit, so this would be a, and b is the upper limit, so this would be b. Hence, our next step should be finding out the values of a and b. Well, how do we do that? Well, we know that the Cartesian equation of the curve C is x squared is equal to minus y to the power 4 plus 2y to the power 3. Well, we know that the curve looks something like this on a proper axis. So this is our y-axis, and our x-axis is somewhere over here. So we're not going to draw the x-axis just yet. So this is our y-axis, and the curve looks something like this, where this coordinate is 0a, and this coordinate is 0b, at the peak and the base of the curve individually. Now, if this point is 0a and this point is 0b, we can substitute x is equal to 0 into our Cartesian equation over here in order to find out the values of y. In that case, 0 is equal to minus y to the power 4 plus 2y cubed. And we can rearrange this to form 0 is equal to y cubed multiplied by y plus 2, as we can multiply both sides by minus 1 and factor out a y cubed from this expression. And thus, solving for y, we get y is equal to 0 or y is equal to minus 2. And these are the only values of y in which x is equal to 0. And thus, the value of a will be minus 2 and the value of b will be 0. And hence, our axis actually lies over here, across the peak. Thus, in order to find the volume of the pendant, we can use our volume of revolution formula with a is equal to minus 2 and b is equal to 0. So our volume of pendant is equal to pi times the integral between minus 2 and 0 of x squared. Well, we know x squared because in part A, we found that x squared is equal to minus y to the power 4 plus 2y cubed. So we can substitute in our Cartesian equation for x squared into our volumes of revolution formula to give you pi times the integral between minus 2 and 0 of minus y to the power 4 plus 2y cubed. Now we can take the minus out of the integral to form minus pi times the integral between minus 2 and 0 of y to the power 4 plus 2y cubed with respect to y. And we can then integrate this integral to give you minus pi multiplied by, well, the integral of y to the power 4 will be 1 over 5 times by y to the power 5. And the integral of 2y to the power 3 will be a half times by y to the power of 4. And this is between minus 2 and 0. So now we have to plug in 0 and minus 2 into our equation. And this leaves us with minus pi multiplied by 1 over 5 times by 0 plus a half times by 0. And you want to subtract 1 over 5 times by minus 2 to the power 5. Subtract a half times minus 2 to the power 4. And this leaves you with minus pi multiplied by minus 1.6. And hence this gives you 1.6 pi centimeters cubed as our volume of revolution. Hence, the volume of the pendant is 1.6 pi centimeters cubed. If you want to leave it to 3 significant figures, this will be approximately equal to 5.03 centimeters cubed. Now that we've answered part B, let's find out where the marks are. You get 1 mark for identifying that the volume of revolution can be written as pi multiplied by the integral between minus 2 and 0 of x squared with respect to y, and substituting in minus y to the power 4 plus 2y cubed into x squared. We get another mark for then integrating this expression and putting it in this form. You get another mark for putting in the limits and writing it out in this expanded form. And you get your final accuracy mark for finding the correct solution at the end. In this question, we're given that the line L1 has equation x minus 2 over 4 is equal to y minus 4 over minus 2, which is equal to z plus 6 all over 1. The line L2 is the reflection of the line L1 in the plane pi. We need to find a vector equation of the line L2. So in summary, we're given a line and a plane, and we're told that this line L1 has a reflection in the plane and it forms line L2. Well, the first thing we should do is deal with these Cartesian equations for the line and the plane respectively, because we can write these in a more workable form to help us with our question later on. For example, one form that we could work with much more easily would be column form. So we need to rewrite the line L1 and the plane pi in column form. Well, how do we do that? Let's work with the line L1 first. The Cartesian equation of any line can be rewritten as such. X minus x1 over a is equal to y minus y1 over b, which is equal to z minus z1 all over c. The column form of this will just be r is equal to x1, y1, z1 plus lambda a, b, c, where lambda is a scalar constant. So the line L1 can be rewritten as r is equal to, well, x1 will be 2, y1 will be 4, and z1 will be minus 6, because over here in our question we have a positive 6, so we need to remember to take the negative of this. So we have r is equal to 2, 4 minus 6 plus lambda times by, well, a will be 4, b will be minus 2, and c will just be 1. And thus we have our column form for the line L1. Now we have to find the column form for the plane pi, where the Cartesian form of any plane is equal to a times x plus b times y plus c times z is equal to some scalar constant k. Its column form will be written in the form r dot, which is the dot product, its normal vector, which is a, b, c, which is equal to k, which is its scalar constant. So in this case, our plane pi can be rewritten as r dot, a will be 1 as the coefficient of just x will just be 1, b will be minus 2 as the coefficient of y is minus 2, and c will just be 1 as well because the coefficient of z is also 1. And our scalar constant will just be 6. Great, so now that we have the column form for both line L1 and plane pi, we can now draw a diagram in order to illustrate our question in more detail. So what will our diagram look like? Well, we have our plane pi as such. This is our plane pi. We have our line L1, which looks something like this. And then we have our line L2, which looks something like this, drawn in green. Remember, this is line L1 and this is line L2. Now you may be thinking, why is pi represented by a line over here? Isn't it supposed to be a plane? Don't planes look something like this? Well, that's true. This is our plane pi over here. And according to this diagram, L1 will look something like this, where it passes through pi. This is L1. And L2 will be the reflection of this. So it passes through pi like this. This is L2. However, if you imagine the plane pi as a piece of paper, you can rotate the piece of paper such that it faces you this way. But from our perspective, it would look something like a line. This is what we've shown in this diagram over here. Great, so now we have our diagram for the situation over here as the line L2 is a reflection of the line L1, because if you take this section of L1, you can reflect it in the plane pi to form this line, which is part of L2, and similarly, if you reflect this section of the line L1, you can form this section of the line L2, and thus L2 is a reflection of the line L1. Now, in order to find a vector equation of the line L2, we need 2 points on our line L2. Our column form of our line looks something like this. R is equal to x1, y1, z1 plus lambda times by a, b, c. While x1, y1, z1 will just be any point on the line, so any position vector, and a, b, c will be a direction vector that gets us from one place to the other place on the line. However, in order to find a, b, c, we will need 2 points in order to determine a direction vector on the line L2. And thus, we need a minimum of 2 points in order to find a vector equation for our line L2. So, looking at our diagram, which 2 points could we possibly use in order to find our vector equation of the line L2? Well, we can see over here that our line L2 actually crosses with the line L1 at this point on the plane pi. This is because if you imagine touching your pen against a mirror, you'll notice that the reflection of your pen also touches the mirror at the same point, and the same logic can be applied over here. When L1 is reflected in the plane pi, its reflection will touch plane pi at the point at which L1 touches plane pi. Okay, so now we have 1 point. How are we supposed to find the other point? Because we need a minimum of 2 points in order to find the vector equation for L2. Well, from our column form of our equation, we can see that we know one of the points on the line L1. That will just be 2, 4, minus 6. Let's label this Q. So this point over here, Q, will be 2, 4, minus 6. And if I extend our line L2 a bit more, we can see that if we draw a straight line that is perpendicular to our plane pi, then we can find the point at which this straight line intersects our line L2 over here. Let's call this Q dashed. Now we'll find out how to find the point Q dashed in a bit, but first let's find this point, which we'll label P. P is the point of intersection between the line L1 and the plane pi. Well, the first thing we can do is shorten our column equation for the line L1 into a more compact form, adding together the position vector and the direction vector multiplied by the scalar constant. So a more compact form can be written as R is equal to 2 plus 4 lambda, 4 minus 2 lambda, and minus 6 plus lambda. And once again, pi will remain the same, so pi is equal to R dot 1 minus 2, 1 is equal to 6. And because at this point, our r's would be equal, because at this point, the line L1 intersects with the plane pi, we can put the r value for L1 at this point into our equation for pi to form 2 plus 4 lambda, 4 minus 2 lambda, minus 6 plus lambda, dotted with 1 minus 2, 1 is equal to 6. And we can perform the dot product on this in order to obtain 2 plus 4 lambda multiplied by 1, minus 2 multiplied by 4 minus 2 lambda, plus 1 multiplied by minus 6 plus lambda is equal to 6. We can simplify this to form 2 plus 4 lambda, minus 8 plus 4 lambda, minus 6 plus lambda is equal to 6. We can bring all the constants to the right-hand side and leave with the lambda terms on the left-hand side to form 9 lambda is equal to 18, and thus lambda is equal to 2. Now at this point P, our position vector of r, is such that lambda is equal to 2, And hence our point P can be rewritten as 2 plus 4 times 2, 4 minus 2 times 2, and minus 6 plus 2. And this is equal to 10, 0, minus 4, as we substitute 2 into lambda for our equation for the line L1 over here. And hence we found the point P. So now we found one of the points needed in order to answer our question. So let's write down our position vector for P on our diagram, which is 10, 0, minus 4. We can now find the position vector of Q dashed. Well, as we've shown here, if we draw a line from Q to Q dashed, we can form a line, let's call it L3, which is perpendicular to our plane pi. Well, using this fact that our line L3 is perpendicular to the plane pi, we can thus infer that our direction vector for our line L3, so our ABC for our line L3, is equal to our normal vector for the plane pi. And we know our normal vector for the plane pi because it's defined in our column form, where 1 minus 2, 1 is our normal vector for pi. And thus, our equation L3 can be rewritten as R is equal to some position vector, where we can use our position vector for the line L1 as Q, which is on L1, also lies on our line L3. So we have our position vector 2, 4, minus 6, plus, now let's use some other constant instead of lambda because we've already used lambda over here. So I'm going to use mu multiplied by our normal vector for our plane pi. So it would be 1 minus 2, 1. So now that we have the equation of the line L3, how can we use this in order to find the value of Q dashed? Well, recall that the definition of the equation of a line can be boiled down to 2 points. You have the initial starting vector, which is our position vector Q, and you want to add some scalar multiple constant of the direction vector 1 minus 2, 1. So this is our direction vector 1 minus 2, 1. And starting from the point Q, you want to add some sort of multiple of our direction vector to our line, and that gets you any point on our line. So using that logic, if we start from our position vector Q and add some value of mu multiplied by our direction vector, we can get to Q dashed. Well, you can also note that this length is actually equal to this length over here. So this length from Q to a point on plane pi is equal to the point on plane pi to Q dash over here, because Q dash is a reflection of Q in the plane pi. And thus, if we find the associated value of mu to get from Q to this point, let's call it R, so this has an associated value of mu that we need to find, we can double this associated value of mu in order to get to Q dashed. So this entire length here will need an associated value of 2 mu. So we can rewrite this as such. This direction vector over here will have some associated value of mu, which we will call mu. And we can double this direction vector over here to get to this direction vector over here, which will have associated value of 2 mu. Because once again, this length is the same as this length. Great, so now we can use the same method we used in order to find the point at which L1 crosses plane pi, in order to find the point at which L3 crosses plane pi, in order to find the value of R. So once again, we can rewrite L3 as R is equal to 2, 4, minus 6 plus mu multiplied by 1 minus 2, 1. So once again, we can rewrite this in a more compact version. So we have R is equal to 2 plus mu, 4 minus 2 mu, and minus 6 plus mu for our line L3. And once again, our equation for the plane pi will be R is dotted with 1 minus 2, 1 is equal to 6. And thus, once again, we can substitute our value of R over here into our value of R over here because we want to find the intersection. So we have 2 plus mu, 4 minus 2 mu, minus 6 plus mu, dotted with 1 minus 2, 1 is equal to 6. Once again, we can perform the dot product on this in order to form 2 plus mu minus 2 times by 4 minus 2 mu minus 6 plus mu is equal to 6. We can expand and simplify in order to form 2 plus mu minus 8 plus 4 mu minus 6 plus mu is equal to 6. And once again, we can move all of our constants on the right-hand side and leave all of our mu terms on the left-hand side in order to form 6 mu is equal to 18, and hence, in this case, mu is equal to 3. Once again, we need double this value of mu in order to form our associated value of 2 mu in order to move up from Q to Q dash. So it will be 3 times by 2, which would be 6, And thus we can use this associated value of 2 mu in order to find the equation q dashed. So plugging in our value of 6 into our equation for r, for our line L3, we'll have 2 plus 6, 4 minus 2 times 6, and minus 6 plus 6, which will just give you 8, minus 8, and 0. Great, so now that we have both q dashed and we have p, we can now use these 2 points, or these 2 position vectors, in order to find our vector equation for the line L2. So in order to do this, we need to choose one point to be our position vector and use both points in order to find our direction vector. In this case, I'm just going to choose p as our position vector, but you can also choose q dashed. And I'm going to use pq dashed as my direction vector. So the equation of my line will be L2 is such that r is equal to my position vector, which in this case I will put as 10, 0, minus 4. So it's 10, 0, minus 4, plus some scalar constant, which I'll use gamma in this case, gamma multiplied by my vector pq dashed. And in order to find out this, I'll just do q dashed minus p. So I'll have 8 minus 8, 0, minus 10, 0, minus 4, which will just be equal to minus 2, minus 8, 4. And this will be pq dash, so we can substitute this into our equation over here. So we have minus 2, minus 8, 4. And this will be the equation of my line L2. And hence, we've solved the question. This is our vector equation for the line L2. Great, so now that we've answered our question, let's find out where the marks are. You get 1 mark for finding out a value of lambda, so lambda is equal to 2 in this case. You get another mark for substituting this value of lambda into our equation for the line L1, so we get 10, 0, and minus 4 as our position vector for p. You get another mark for finding out our value of mu, so in this case mu is equal to 3, and using this logic to find out that 2 mu is equal to 6, and substituting this value of 6 into our equation for the line L3, and you get another accuracy mark for writing out the correct position vector of q dash. You get another mark for using our knowledge of the equation of line in order to determine the direction vector of pq dash, and then writing this in the actual equation of the vector form of the line, and this is our final accuracy mark. The company plans to build a fairground ride. The ride will consist of a capsule that will hold the passengers, and the capsule will be attached to a tall tower. The capsule is to be released from rest from a point halfway up the tower and then made to oscillate in a vertical line. The vertical displacement, x meters, of the top of the capsule below its initial position at the time t seconds is modelled by the differential equation m multiplied by the second derivative of x plus 4 multiplied the first derivative of x plus x is equal to 200 cos t, where t is greater than or equal to 0, and where m is the mass of the capsule, including its passengers, in thousands of kilograms. The maximum permissible weight of the capsule, including its passengers, is 30,000 newtons. We're also given the value of g to be 10 meters per second squared, and we need to assume the capsule is at its maximum permissible weight. So for part AI, we need to explain why the value of m is 3. Well, in order to answer this question, we need to use this information, that m is the mass of the capsule, including its passengers, in thousands of kilograms. Well, we know that weight is equal to big M multiplied by g, where big M represents the mass of the object in kilograms. So we can substitute in our value of 30,000 newtons into our value of weight and our value of 10 meters per second squared into our value of g, in order to give you 30,000 newtons is equal to m multiplied by 10. We can then divide both sides by 10 in order to give you big M is equal to 3,000. Well, if big M is equal to 3,000 and big M represents the mass of the capsule in kilograms, then small m is the mass of the capsule in thousands of kilograms, and thus small m is equal to big M divided by 1,000, which would just be 3. So thus, small m is equal to big M divided by 1,000, which is equal to 3. Thus, m is equal to 3. And we have thus shown that m is equal to 3. For part II, we need to show that a particular solution to the differential equation is x equal to 40 sin t minus 20 cos t. Well, if this is the particular solution to the differential equation, then if we substitute this into our left-hand side of the differential equation, we should get 200 cos t on the right-hand side. Well, in order to substitute this function into our differential equation, first we need to find the second derivative and the first derivative of x. So we have x is equal to 40 sin t minus 20 cos t. We need to find the first derivative of x, so we should differentiate this once. So dx by dt is equal to 40 cos t plus 20 sin t. And the second derivative of x will just be the derivative of x, which will be minus 40 sin t plus 20 cos t. Now, in order to verify that x is a particular solution to the differential equation, we need to substitute these values back into our differential equation on the left-hand side and see if it gives us 200 cos t. So our differential equation is 3 multiplied by the second derivative of x plus 4 multiplied by the derivative of x plus x, and thus let's substitute our values. So we have 3 multiplied by, well, the second derivative of x will be minus 40 sin t plus 20 cos t, plus 4 multiplied by the derivative of x, which is 40 cos t plus 20 sin t, plus x, which is just 40 sin t minus 20 cos t. Well, 3 multiplied by minus 40 will be minus 120 sin t, and 3 multiplied by 20 will be 60, so you have 60 cos t. 4 multiplied by 40 will be 160, so you have 160 cos t. 4 then multiplied by 20 will be 80, so you have plus 80 sin t. And then you just add 40 sin t minus 20 cos t. Let's simplify this a bit more to give you, well, we can group up all of the sine terms to give you, well, minus 120 sin t plus 80 sin t plus 40 sin t will just be 0. And 60 cos t plus 160 cos t minus 20 cos t will give you 200 cos t. So this is equal to 200 cos t. And thus, because the left-hand side of our differential equation is equal to the right-hand side when x is equal to 40 sin t minus 20 cos t, we know that x must be a particular integral of our differential equation. Now, for part I, we need to hence find the general solution of the differential equation. Well, now we know that x, which is 40 sin t minus 20 cos t, is a particular integral of our differential equation, and thus, in order to find a general solution of our differential equation, we need to find the auxiliary equation. Well, we know that our differential equation is 3 multiplied by the second derivative of x plus 4 multiplied by the derivative of x plus x is equal to 200 cos t, and thus our auxiliary equation will be 3 lambda squared plus 4 lambda plus 1 is equal to 0. We need to solve this equation in order to find our values of lambda, so I'm going to solve it by factorizing, but you can solve it any other way. So by factorizing this, we have lambda plus 1 multiplied by 3 lambda plus 1 is equal to 0, and thus lambda is equal to minus 1, and lambda is equal to minus a third. And now we need to find the discriminant of this auxiliary equation in order to find out what form our general equation will be written in. So the discriminant of our auxiliary equation will be b squared minus 4ac, which is 4 squared minus 3 times 1 times 4. And this will be equal to 16 minus 12, which will be equal to 4. And 4 is greater than 0. So our general equation will have the form x is equal to a e to the power of alpha t plus b e to the power of beta t plus our particular integral. In this case, alpha is equal to minus 1 and beta is equal to minus 1 over 3, which we get by solving our auxiliary equation in order to find lambda. So we have x is equal to a e to the power of minus t plus b e to the power of minus 1 over 3 multiplied by t. And so this is our complementary function we have over here, which we obtain by using the auxiliary equation. Because the general equation of x will be our complementary function plus our particular integral, we need to add our particular integral into our complementary function to form a e to the power of minus t plus b e to the minus a third t plus our particular integral will be 40 sin t minus 20 cos t, which is what we proved in our previous part. So 40 sin t minus 20 cos t. And this is our general equation for x. And thus we have answered part A. A part I is only 1 mark, so you get 1 mark for showing the value of m is 3. A part II is 3 marks, so you get 1 mark for differentiating x twice. You get another mark for realizing that you have to substitute these values back into our differential equation, so this substitution right here. And you get a final accuracy mark for showing that the left-hand side is equal to our right-hand side, which is 200 cos t. For part III, you get 1 mark finding out the values of lambda. You get another mark for showing that the complementary function is a e to the power minus t plus b e to the power minus a third t. You get another mark for noticing that our general equation of x has to be the complementary function plus the particular integral. And you get a final mark for writing the general solution of the equation correctly. For part B, we want to use the model to find to the nearest meter the vertical distance of the top of the capsule from its initial position 9 seconds after it is released. Well, this means that we need to use our general equation from what we found in part A in order to find a particular equation or particular solution to our question. Well, how do we do that? We need initial conditions from our block of text over here. Well, it doesn't give us our initial conditions explicitly, but we can derive some initial conditions from this text, because we know that the capsule is to be released from rest at a point halfway up the tower and then made to oscillate in a vertical line. Well, using this information, because the capsule will be released from rest, we know that x is the displacement. Then, at t is equal to 0, which is the initial time, x is equal to 0, and dx by dt is equal to 0. Because x is the displacement, and if you differentiate displacement, you'll get the velocity of the capsule, and the velocity at the beginning is 0 because the capsule is released from rest. Well, we know once again that our general equation is x is equal to a multiplied by e to the power minus t plus b times e to the power minus a third t plus 40 sin t minus 20 cos t. And once again, our initial conditions are at t is equal to 0, x is equal to 0, and dx by dt is equal to 0. And thus, we can substitute our values into our general equation in order to try and solve for a and b. Now, let's use our first two set of conditions, that at t is equal to 0, x is equal to 0. So at t is equal to 0, x is equal to 0. So 0 is equal to a e to the power of, well, minus 0 will just be 0, plus b e to the minus a third times 0 will be 0, so b e to the 0 plus 40 sin t, well, sine of 0 will be 0, so it'll be plus 0 minus 20 cos t, well, cos of 0 will be 1, so it will just be minus 20. So thus, 20 is equal to a plus b, because e to the power 0 will just be 1. Now let's differentiate our general equation to give us a value of dx by dt. So dx by dt is equal to minus a e to the minus t by differentiating a e to the minus t minus a third b e to the minus a third t plus 40 cos t plus 20 sin t. And we can use these two initial conditions, that t is equal to 0, dx by dt is equal to 0, in order to substitute into our general equation for the derivative of x, to give you 0 is equal to minus a, because once again, e to the power 0 will just be 1, minus a third b, plus, well, cos of 0 will once again be 1, so 40 multiplied by 1 will be plus 40, plus 20 multiplied by sine of 0, which will just be 0, so it will just be plus 40. This will give us the equation a plus a third b is equal to 40. And now look, now we have simultaneous equations, as this is our first equation and this is our second equation. We can subtract our first equation from our second equation as such. A plus b is equal to 20, and a plus a third b is equal to 40. So subtracting, we have 2/3 b is equal to 20 minus 40 will be minus 20. So thus b will be equal to minus 30. We can substitute this back into one of our simultaneous equations. So I'm going to substitute it into the first one to give you 20 is equal to a minus 30, and thus a is equal to 50. Hence, we know that b is equal to minus 30 and a is equal to 50, so we can substitute this back into our original general equation in order to find our particular equation. So we have x is equal to 50 e to the minus t minus 30 e to the minus 30 plus 40 sine t minus 20 cos t. And thus, we can go back to our question over here. We want to find the vertical distance of the top of the capsule from its initial position 9 seconds after it's released. So 9 seconds after it's released, the value of t will be 9. So when t is equal to 9, then x is equal to 33 meters to the nearest meter. And hence we have answered part B. For part B, you get 1 mark for noting that the initial conditions are at t is equal to 0 and x is equal to 0, and using this in order to find our first homogeneous equation, so 20 is equal to a plus b. You get another mark for differentiating our general equation for x, obtaining a plus a third b is equal to 40. You get another mark for finding out the value of a and b and substituting it back into our general equation to give you x is equal to 50 e to the minus t minus 30 e to the minus a third t plus 40 sine t minus 20 cos t. And you get your final accuracy mark for arriving at the correct answer, which is 33 meters.